In single loop control configurations, each PID controller outputs directly to a final control element. But in the configuration proposed for the furnace, the hot air temperature controller outputs to a summer, which in turn outputs to the final control element. Such configurations go beyond single loop control. This raises some configuration issues for PID blocks. Traditionally, the controller output has been expressed as percent of span. One consequence is that the controller gain is expressed as percent to percent, or more specifically, the change in controller output as percent of span divided by the change in measured variable as percent of span. For the modified control configuration, all outputs are expressed as percent open. We view percent open as the engineering units for the controller output. For most final control elements, the output range is 0 to 100% open. When a PID controller outputs directly to a final control element, the output in percent of span is numerically equal to the output in the engineering units of percent open. However, this is not generally the case when a summer is inserted between the controller output and the final control element. The output of the characterization function is the ideal fresh air damper opening. The output of the summer is the actual fresh air damper opening. What is the output of the hot air temperature controller? The difference between the actual and the ideal openings are specifically the actual opening less the ideal opening. The sign matters. The coefficient on the input to the summer must be consistent with how the difference is defined. How do we obtain an actual opening that is less than the ideal opening predicted by the characterization function? Negative values must be allowed for the numerical value of the output of the hot air temperature controller. The output of the hot air temperature controller is the actual fresh air damper opening less the ideal fresh air damper opening. For each, the engineering units are percent open. The engineering units for the hot air temperature controller output are percent open. However, it is not the opening of any final control element, but instead is the difference in two values in percent open. To cover all possibilities, the lower output range for the hot air temperature controller must be minus 100% open. This enables the hot air temperature controller to fully close the fresh air damper regardless of the output of the characterization function. The upper output range must be plus 100% open. This enables the hot air temperature controller to fully open the fresh air damper regardless of the output of the characterization function. The simulator will display and accept values for the controller output in either engineering units or percent of span. For the hot air temperature controller, these are not numerically equal. Left-click the TC element to open the point window. The current output in engineering units is minus 0.1% open. For an output range of minus 100% open to plus 100% open, the output is 49.95% of span, which displays as either 49.9 or 50.0% of span. Let's examine the configuration of the hot air temperature controller. From the point window, open the configuration window. The output range is specified on the General tab. The lower output range is minus 100% open. The upper output range is plus 100% open. The output limits provide a small overrange, but this is not necessary. A more appropriate role for the output limits is to restrict the feedback trim to a narrower range. Suppose we specify minus 10% open for the lower output limit. The actual fresh air damper opening can be no more than 10% less than the output of the characterization function. The most convenient approach to implementing control configurations that include characterization functions, summers, and the like is for the output of all PID controllers to be expressed in engineering units. When the output value pertains in any way to a final control element, the output range for the PID controller is preferably expressed in the engineering units percent open. Control configurations are easier to understand when implemented this way. For configurations containing characterization functions, summers, and the like, the configuration of PV tracking may have implications on the initialization of the control configuration. In the configuration we shall propose for the off-gas process, it does not. We shall configure all PID controllers for no PV tracking, but we could do the opposite. For the simulator, the configuration for PV tracking is on the Set Point tab. The option Tracks Process Variable means PV tracking is on. The option Holds Current Value means PV tracking is off. By configuring no PV tracking, the set point does not track the PV when the controller is in manual. When we switch a controller to manual, the value of the set point will not change. In manual, we are permitted to change the set point. When the controller is switched back to auto, the value of the set point is not affected. The bumpless transfer calculations will initialize the PID equation such that control commences from the last output value in manual. But if the PV is different from the set point, the controller will start driving the output up or down depending on the sign of the control error. Commissioning the ratio control configuration that uses the characterization function is the subject of the next video.